What's up? Welcome back. Today we are going to talk about topic 5, day 3. So you're stuck with me again. The last 2 days you had Miss Davenport on the notes, and now I'm back, suckers. So, topic 5, day 3, features of functions. All right. So I've already given you some of the definitions up here, some different things we're going to find in these graphs. So the first one is increasing interval. All right. So the graph goes up from left to right. So that should kind of make sense to you. Increasing, hopefully we all know, means to go up, right? So increasing, it is going up. The same thing is also true. Decreasing means it goes down. Okay, so the graph is going down from left to right. Okay, we are always looking, just like when we read a book, we go from left to right. Same thing applies with a graph. Okay, a constant interval, the word constant means it doesn't change. So again, the definition, the graph doesn't change from left to right. Okay. Now, there's two other things that you learned in Algebra 2 and Algebra 1 and Geometry that you might have forgot about. All right, so one is called the maximum, the relative maximum, and that is basically the top of a hill. Okay, so that's where the graph starts to turn, so the top of that hill. The minimum is like the bottom of a valley. So a maximum would be something like this, right, at the top of the hill. The minimum would be something like a valley. But these are relative max and min, so there could be more than one. Right, so I might have a graph that looks like this, that goes, and then maybe it has another hump in there. So look, there's two relative maximums, right? Just depending on the problem. There could be more than one, right? There might not be. It just all depends on the problem, okay? Now, this section, a lot of this is going to be done in Desmos. So we are going to graph a lot of this so that we can see the graphs so we don't have to draw them all by hand. I know how much you all love drawing graphs. So this first example right here, I've already given you the graph. Okay, so I went on Desmos and typed this in and just put it on this sheet. All right, and we're going to find all this stuff over here. So the first one says find the increasing interval. So I want to look at this graph and figure out where it's going up. Okay, and again, I always start on the far left, so way over here on this side. Right, this graph is going down and out forever. So it is going to the left forever and ever and ever. So it's going up, 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 until I get to right here. So this graph is going up from left to right. So that would be negative infinity. And remember, infinity always gets a parenthesis until I get all the way up here to 1. I always use the x values. Okay, don't ever use the y values. You will never, ever, ever, ever use the y values when you're looking at increasing or decreasing. Okay, always the x values. So it went from negative infinity to 1 is the increasing part. Then the opposite is also true. Once I get to that turning point, the graph starts to go down from left to right. So I'm going, it's decreasing, so that's from 1 with the bracket, and then it goes out to the right forever. Okay, and if I go to the right, that is positive infinity. So from 1 to positive infinity. Okay. The next question says the maximum or minimum. All right, this graph has a maximum right here. That's the top of the hill. So this would be our maximum. This graph doesn't have a minimum, right? Because it just keeps going down forever and ever and ever. So there's going to be no minimum, but there is going to be a maximum. And it's that point, whatever that ordered pair is, which in this case is 1, 4. Okay. Okay. The next one is zeros. Okay, so another way to think of zeros is just the x-intercepts. You might also hear roots, solutions, zeros, x-intercepts. They are all the same thing. All right. So again, we just look at the graph. It crosses that. It's probably kind of hard to see on your end, but that's a -1 and that's a 3. So wherever it crosses, so x equals -1 and 3. All right. You could also write those as ordered pairs. So you could write it as -1, 0 or 3, 0. Right? Either one of those is acceptable. They both work just fine. Okay? The last question is a constant interval. So this graph doesn't have a constant interval. So a constant interval would be a straight line going side to side, meaning it's not going up, it's not going down. So this one does not have a constant interval. All right? Okay, let's try one more that's a little bit harder. So this one is a piecewise function. Okay, so it just looks a little bit different. But we're still going to find all the same stuff. So the first one says increasing. So this graph is increasing. So look at the graph. It starts here, then it goes straight across, then it goes up and over, and then there's an open circle, and it goes down there. So it's right there in green. All right. So it starts at -5. Then it goes over. Notice this doesn't change, right? So that part would be constant. This first piece is constant, right? It is never, ever, ever changing. So from -5 to -2 is constant because that piece doesn't go up, doesn't go down, just stays the same. Once we get to -2, then the graph starts to go up, okay? And it goes up, 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 up until we get to right here. Right? It keeps going up until we get to this point. So it's increasing from, again, use the x values, from -2 to 0 with a bracket. Sorry. Once you get to 0, right, then the graph starts to decrease. So now for the decreasing part, we're actually going to have two answers here. So the decreasing, at 0, it starts to decrease, and then it decreases to here, right, to this point. So from 0 to 1, it decreases. And then there's a gap, right? And then there's a hole in the function. I shouldn't say hole, that's a different thing, but there's a gap in our graph. Then it picks back up here at 2. Okay, and notice that that 2 is an open circle. So that 2 gets a parenthesis because it's open, and then it keeps going down, decrease, 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 until we get to 5. So this piece is decreasing, and this piece is decreasing. This piece is increasing, and this part is constant. Okay, so we pick all of those different things out from the graph. And we always look from left to right. Okay. All right, the next question says max or min. This graph has a maximum right here. Right, that's the top of the hill. Okay, so it has a maximum right there, which is at 0, 4. So the point is 0, 4. 0, 4. Now, does this graph have a minimum? Right, does this graph have a minimum? Right, it stops right here, right? So our minimum of this graph is this point. So this would be our minimum, 5, -2. 5, -2. Questions? Okay, the last part. This graph has zeros, has a lot of zeros, right? I don't know why I just said questions like I'm in class. That was stupid. Has a couple of zeros, right? So we have -2 and we have 3 as our zeros. Because remember, zeros is x-intercepts, all right, is roots, is solutions. All of those things are the same thing, okay? All right, the last thing we are going to talk about is even, odd, or neither. All right, and the good news is that we can do this in Desmos. All right, so just like on the front, right, I gave you the graph. You're going to be given the equations. You're just going to type the graph in Desmos and just look at it. All right, so you actually don't need to graph them by hand. All right, same thing we are going to do back here. So there's a couple of different kinds of functions you can have. If something is an even function, this is going to be a brain buster. It's an even function if the biggest exponent is, guess to yourself right now, is an even number. Oh my God. The biggest exponent is an even number or its absolute value. That's what we call an even function. Okay? And even functions are going to have vertical line symmetry. So basically, if you drew a line right down the middle, like here's the graph for this one. If you drew a line right down the middle, right, it would be the same on the left and the right. So we know that this function is even. Same thing over here. I know this graph is hard to see, but we have this graph. So this is the graph of absolute value. If you drew a line right down the middle, it would be the same on the left and the right. So that's how we know that something is an even function, because it's going to be equal on left and right. Okay? You can figure this out algebraically as well. Okay, so if f of -x equals f of x, then they have to be the same. So basically, if the left side equals the right side, right, if it's the same on both sides, then it has to be even. All right. So for example, if f of x was absolute value of x plus 4, if you simplified that, you would get x plus 4. Same exact thing would happen if you made the x negative. The absolute value of negative x is x, and then the plus 4 stayed the same. So if you notice, these two things are exactly the same, right? The f of x is x plus 4, the f of negative x is x plus 4. So they are identical. So since they are the same, that means this is an even function, okay? So again, if you're unsure, look at the exponent, all right, or graph it in Desmos and look for symmetry, all right? The other option is an odd function, okay? So an odd function, same thing is going to occur. I bet you're probably struggling figuring this out. The biggest exponent is, go out on a limb, odd. Okay, so the biggest exponent is odd. And odd functions have what we call origin symmetry. So for example, if we had this line right here, right at the origin, they are symmetrical now. Okay, the same thing applies to this graph. At the origin, they have symmetry. So you'll notice it's not the exact same on the left and right. It's not like these two, right, where they have vertical line symmetry. These have symmetry at the origin, okay? And algebraically, the same thing would occur. F of negative x equals negative f of x. So f of x equaled x, and f of negative x would then equal negative x. Because if you put a negative sign in with the x, it just makes it the opposite. And look, that is the case. F of negative x equals negative f of x. Okay, but again, if you are stuck, just put it in Desmos, right? If you forget about the even, odd, and the exponents, just put it in Desmos and look, okay? Those are our notes for topic 5, day 3. You have your Math Excel assignment. Knock that out. Remember, Desmos, Desmos, Desmos. Appreciate you. Deuces.